Good evening. It's evening for me. I'm recording lesson 8.3. It's part 2 for volume of revolution, where we're going to work with disk and washer. The only change is we're going to move that axis of rotation. On part 1, all we did was keep the axis of rotation on the x-axis or the y. Now we're going to do some shifting around. So we've got 3 examples coming your way. I'm sure you'll catch on just as soon as we get through those 3. Example 1, the region bounded by the graphs of y equals 1/2 x squared plus 3 and y equals 1/3 x plus 1. And by the vertical lines, x equals -2, x equals 3, and it's revolved. This region is revolved about the line y equals 8. Find the volume of the resulting solid. So we talked about, we mentioned this function here. So there's our parabola. We mentioned the linear function. I can see that in the light blue. And we had 2 vertical lines set up. We had an x equals -2 and an x equals 3 line. So everything is plotted out, and I can see the yellow space that we're going to revolve. We're going to revolve this about the line y equals 8. So I've got that dark red line up above, and we're going to revolve this object around that. So since I see that gap, that white space there, I know that I'm working with a disk method. So I'm going to use disk method, and we're going to have a big R and a little r. I'm going to start from my axis of rotation to define my r. So the outer r, the largest volume, would be resulting from the axis rotation to the outside, or the outermost, the farthest away function, which is that linear function. The parabola function is inside or closer to the axis of rotation. So I'm going to call this my big R, and big R is going to be a top minus bottom calculation, and my top is 8. My bottom function is 1/3 x plus 1. So I could say I think I'll just leave it there. I was going to simplify, but I think I'm just going to leave it there. All right, then little r is going to go from my axis of rotation to the function that's in the inner part, that's going to really result in the void area, the hole, the region that is generating the hole. So that's going to be little r. And once again, for little r, it's going to be a top minus bottom, because I'm working in x's since I'm rotating about a horizontal line. We could see if we created that disk, and there's the washer. This inside piece here, this inner, would generate the hole to the washer. And since we're rotating about an axis that's parallel with the x-axis, my washer kind of sits in here like so. So it has a thickness of dx this way. Okay, so I'm going to take and erase just a bit so I can see what I got going. And that's going to be the top function 8 minus the parabola 1/2 x squared plus 3. And I'm just going to leave it like that. So there's little r, and then we had big R. Now the formula stays the same as it did in washer method without moving our axis of rotation. And so my volume is going to be pi integration x values, -2 to 3, -2 to 3, big R squared. So my big R is going to be 8 minus 1/3 x plus 1 quantity squared. Now that would not be correct, because I didn't put my parentheses around that linear function. So either distribute the negative or use the parenthesis. Minus, I got to get a hold of this and move it. Okay, there, we got it out of the way. Minus, now let's go after little r squared. Minus 8, take away, parenthesis, 1/2 x squared plus 3, the parabola. And then that gets squared. And all of this gets multiplied by the thickness dx. So it's quite complicated, isn't it? We could simplify it down some. It would have been okay to write -2 to 3. I would have had 8 minus a 1 inside there, so I could have 7 minus 1/3 quantity, x, 1/3 x, quantity squared minus, this would have been an 8 take away 3, so a 5 minus 1/2 x squared dx. And that might have been nicer to key in my calculator. I probably would have done that much. I'm not going to have us obviously work this by hand because that would be a bit of a mess. And the answer comes out to be pi times 154.213, which comes out about 484.474. And it would be cubic units, whatever those units were measured in. Okay? I think the biggest mistake people continue to make, are you need each of those r squared. Okay, so keep that in mind. And the other thing people will tend to forget is the pi out front. And that pi is really there to make the area of a circle, because this really is a cross-sectional piece. It's just a disk or washer cross-sectional. Example 2, sketch the region R bounded by the graphs of x squared, y equals 4, and find the volume of the solid generated if R is revolved about the line y equals 4. So let's get sketching here. I think I want to I'm thinking here's probably not too bad a choice for my x and y axis. And we've got the line y equals 4, 1, 2, 3, 4. So that's going to be my axis of rotation. I'm going to make it black there. So this is y equals 4. This is the one we're revolving about. So we got another horizontal axis of rotation. Everything will be worked in dx style. And then we've got x squared getting plotted out. So 0, 0, 1, 1, up 2 over 1, 2, 4, -2, 4. And that's going to look like that. And it looks like that region is what gets revolved, doesn't it? So let's just shade in that whole entire region. And what is the thickness of the washer? Well, we talked about, since it's a horizontal axis of rotation, our R that connects to this would be along here. And is this disk or washer method? Well, since I'm rotating about y equals 4, and our shading goes right up to there, there's no gap in between the axis of rotation and the figure, so we would have disk method on this. This is going to be disk. I guess I could have just circled that, couldn't I? We are working disk here. My R, there's one R. I'm just going to call it a big R. It's going to start from 4 and stretch out to the curve, the region bounded by that curve. Okay, so big R in this case is going to be top minus bottom again. That's how I can find length of my R. And that means big R is 4 take away, just a nice little x squared function. And that leads us into volume equals pi integral. We know that this is going to be -2 to +2 x values, again, of big R squared. So 4 minus x squared quantity squared dx. We probably could do this one out by hand, I guess. We could square that out, couldn't we? So we'd have -2 to 2, 4 squared, 16. At the end, I'm going to have a plus x to the 4th. And then I've got twice the product in between here, so an 8x squared. All of this dx. And of course, we could keep integrating, couldn't we? Don't forget to actually integrate. So I'm going to go ahead and just kind of get this set up. We'd have 16x minus 8/3 x cubed plus 1/5 x to the 5th, evaluated from -2 to +2. All of that multiplied by pi. It might have been nice to double this one because we do have the symmetry. Then I could have brought in a 0 to 2 and done a double. So if you prefer to do it that way, that would just make the hand work a little bit easier. Anyway, when it's all said and done, this one does come out to be 512 pi over 15. Okay? Let's go on to the next one, our final one. Sketch the region R. Oh, we got the same functions, x squared, y equals 4, and volume is generated about the line x equals 2. Oh, okay. Well, let's get our axis of not our axis of rotation, but our x and y axes down. I almost wrote y, wow. And there's y. Then let's get the function 0, 0, 1, 1, 2, 4, -2, 4. Sketch in your parabola. We had the line y equals 4 mentioned. There's y equals 4. And that does define the region. So I'm going to go ahead and just shade this region in. This is what's getting rotated. Now, what was our axis of rotation? The axis of rotation was described as x equals 2, which is going to be right there. So many lines to draw. And this is the axis of rotation, isn't it? So if you can imagine that parabola rotating about, it would have a connecting piece right up here, wouldn't it? And then it would rotate about. We'd have this hollowed out space down below. Is this disk or is this washer? Well, since we're rotating about the green, I see lots of white space, so I know this is a washer. That means I've got a pi big R squared minus little r squared. Dx or dy, I haven't determined that yet. But if I'm rotating about this line, I would have a little r. Axis of rotation is where I always start, and then I draw to my innermost function. That would define little r there. And then let's take and make it to the outermost function, which would be clear over on that left side. That would be our big R. Now, I can see that this rotation, we would have this void area, and then I'd have this large outer there, wouldn't I? And if I drew in that representative washer that would get stacked, we can see that that thickness of our washer is a dy thickness. Whoops. So this is going to be worked in y's, which means I need to convert my equation. Y equals, so let's do a conversion. We had y equals x squared, so that would convert into plus or minus square root y equals x. And yes, indeed, we do have two functions here. This is y. Whoops, this is not y. How do I undo? There we go. This is x equals positive square root y. And over on this side, I've got x equals negative square root y. So that when I put in a y value, such as 1, I'd have square root of 1, but then negative. That describes that x value, doesn't it? And if I put in 1 again for y, I would get out, if I put it over here on the right, if I put 1 in there, I'm going to get out square root of positive 1, and that describes the x value on the right-hand side. So I feel comfortable with my functions. Let's define what big R is. Big R then is going to be, since I'm working horizontally, I always think right minus left. And that means big R would be right is 2. Take away left, which is negative square root y. Looks like big R comes out to be 2 plus root y. Then little r is going to be right minus left. And that would be a 2 minus the inner part of our parabola, which is the positive square root y. So I've got little r, big R. And really, once you get that work done, I kind of think you're home free. So here, let's write the equation. We know the volume equation. This will be a c to d of big R of y squared minus little r of y squared. It probably would be a good idea during your practice sessions that you write out the formula each and every time just to cement that formula. What is my C to D? Well, remember those are Y values. I can tell here we started at 0 and then obviously finished at a top of 4 on that pink line. So 0 to 4, big R was a 2 plus square root Y, quantity squared, minus little r 2 minus square root y, quantity squared, dy. And if you wanted to, you could work that out together. I did not. Answer I'm getting was 128 thirds times pi, which calculates to about 134.041 cubic units. So not a lot different when you're moving your axis of rotation. If you always kind of just keep relying on right minus left or top minus bottom, whatever's on top, if that's my axis of rotation, then that's where I start. Just like we did on this one. Axis of rotation was above our figure, so it went top minus bottom, or right minus left. All right, your homework is going to be delta math, so that should help to cement this concept of disk and washer method with axis of rotation moving from the x and y axis. Good luck.